Okay, so today we're going to talk about some radical functions and their models. This is 8.8. A radical function, as your notes say, it can be described by any radical expression. What we're going to talk about today, it's going to look like a function like we've played with before, but this time it does have that radical in it. So 7 minus 3x. In this case, let's just make sure we remember some vocabulary pieces. Remember, your index is what value of a root you have. In this case, since it doesn't have the root index denoted, it's understood that it's a square root. So the function of the function of x such that the square root of 7 minus 3x. So we understand this, our index is 2, which is an even number. That's important to know because as we're playing with radical functions, if my index is even, then I'm going to have to do some math and solve to find what my domain is. If my index is odd, then my domain is all real numbers. So my domain is negative infinity up to infinity. Okay, that's what we're going to be looking for today, is what is the domain of this radical function. So for this particular problem here, my index is even, and as your notes say, if your index is even, the radicand must be non-negative. So it's going to have some numbers that are not in that domain. In order to figure out what is in that domain and what's not, those non-negative numbers, what we want to do is we want to take my radicand and I want to set it greater than or equal to 0 because I need it to be a non-negative number. So 7 minus 3x is greater than or equal to 0. This will tell me what can x be so that I'm finding the square root of a non-negative number. So now I'm just solving this inequality. Here's my variable. I want to first move this 7 over, so I'm going to subtract 7 on both sides. So now I have a negative 3x is greater than or equal to 0 minus 7, which is just a negative 7. Continue to solve here. I'm going to divide by negative 3. Remember, when you divide by a negative, you must flip your inequality. I usually circle mine just to remind me that I need to do that extra step of flipping my inequality. So what I end up with now, these guys cancel out. So x, remember to flip your inequality because you divided by a negative, is less than or equal to a 7/3. Okay? So that right there, anytime this number, this x, is less than or equal to 7/3, which 7/3 is what, about 2 1/3, I guess, then this is going to be a non-negative radicand. So the way I would write this, and what you're going to want to look for in your My Math Lab, is one of two ways. They may have it set up in set notation, where remember it's x such that x is less than or equal to 7/3. Or it may be written as, remember this is x is less than or equal to 7/3, so it's going to go all the way down to negative infinity because it's less than that, and it can include 7/3. So I'm going to use my bracket because it is less than or equal to 7/3. So it may be written in set notation or it may be written in interval notation as you look at your answer choices in My Math Lab. Okay? Let's do one more of these with an even index, and then we're going to jump to one with an odd index, and you're going to be blown away how easy that is when you have an odd index. Okay, so if I have t of x equaling 2x minus 5, and they want to find out what is the domain of this radical function. Again, you want to take my radicand, set him equal to 0. So 2x minus 5, no, I'm sorry, not equal to 0. You want it to be greater than or equal to 0 because you want to find the non-negative. So I'm going to add 5 to both sides. Those cancel out, so I have 2x greater than or equal to 5. Divide by 2. So my x can be anything that's greater than or equal to 5/2. So again, when I go to write that in that set notation, x such that x is greater than or equal to 5/2, or your choices in My Math Lab may be more in that interval notation to where I'm looking for x to be greater than, oops, I shouldn't have an equal sign, x is greater than or equal to 5/2, so it can include 5/2, And it can be anything greater than that all the way up to positive infinity. And remember, you always use a parentheses around the infinities because you can't include infinity. It's not a place on a number line. So your answer could be written in one of two ways. Again, that's with having an even index. This would be the same way you go about it if it was to the 4th root or to the 6th root or what have you. Now let's play with one with an odd index and see if we can find the domain. Remember back to that rule I shared with you at the very beginning, and it's in the top of your notes. If you have the 3rd root of x minus 12, this is an odd index. You don't even have to do any work. Your answer is a set of all real numbers, all the way down to negative infinity and up to positive infinity. That's your answer. There's no math involved. The domain is all real numbers. All right, good luck. That's 8.8.